In this lesson, our objectives are to be able to draw and calculate angles and also to be able to convert angle measures between degrees and radians. So let's first begin with some vocabulary. An angle that is in standard position is an angle whose vertex is at the origin and whose initial side is the positive x-axis. So if we're talking about an angle in standard position, it would look something like this, where we have the x-axis as being the initial side, and that is one of also our vocabulary words, initial side, being at the positive x-axis, and then we would have our angle being something like this. When you measure an angle, beginning with our initial side being the positive x-axis, if we are going in a counterclockwise direction, which is the example that I have drawn here, that is going to be a positive measurement for our measurement of our angle. If we have an angle such as this, with our initial side again being the positive x-axis, and we are coming down something like this to our angle, that is going to be a negative direction. Now, the ending side of our angle, which would be this ray right here or this ray right here, that is called the terminal side of the angle. So again, the initial side is the positive x-axis, and that is the first ray that forms our angle, and then the second ray forming our angle is called the terminal side of the angle. Now, coterminal angles are angles that are in standard position, again having their initial side as the positive x-axis, and they have the same terminal side. For example, if we have two angles whose initial side again is the positive x-axis and the terminal side is over here, these two angles, this one being our positive and this one being our negative, would be coterminal because they share the same terminal side. The next slide that I would like to show you is the slide of angle measurements and give you an example of what that might look like. So we can begin with our angle measurements of our initial side being the positive x-axis and showing you that as you increase, remember that if we create our circle, we have 360 degrees, but as we continue around, we can add angle measurements and continue around and so on. So this is an example of showing the many different angle measurements as we continue around. Now we need to draw an angle with the given measure that is in standard position, and then we need to tell in which quadrant the terminal side lies. So if we have our y and our x-axis, beginning with our initial side on the x-axis, and we want to go a negative 120 degrees. The first thing that we need to remember is that the negative direction is going clockwise. So we do have this measurement of 90 degrees, our right angle, and then we need to just estimate by adding in another 30 degrees, and this would be our angle that is 120 degrees, which is negative. Drawing an angle that is 400 degrees that is positive. So we'll begin with our x and our y axis and our positive x-axis beginning at our as our initial side of our angle, and we want this to be positive. So this time we are going to need to go in a counterclockwise direction. So we're going to start, and when we go around, the first time around will be 360 degrees, and then we need to add in another 40 degrees, not quite 45. And that will be our angle that measures a positive 400 degrees. So it's once around, and then we add our other 40 degrees. Next, we need an angle that is 40 degrees that is positive. So we begin with our initial side with our positive x-axis, and we need to go in a counterclockwise position to go positive, and we need to be at approximately 40 degrees, so a little bit less than our 45, and that is our terminal side, and that would be our 40 degrees. Now we'd like to take a look at each of the examples and tell which quadrant the terminal side lies in. So remember, the terminal side in example A is the ray that finishes our angle, and it is located, remember our quadrants are labeled as 1, 2, 3, and 4, so this is going to be in quadrant 3. Our terminal side in example B, when our angle is a positive 400 degrees, is going to be in quadrant 1 for our terminal side. As well as example C, our terminal side will be in quadrant 1. In the next example, we would like to find one positive and one negative angle that are coterminal with a negative 100 degrees. Now to do this, what we simply need to find out is, what does negative 100 look like? Remembering that coterminal means that we want to have these two angles begin at our same initial position and then share a terminal side. So if we have negative 100 degrees, negative means that we are going to go clockwise 100 degrees. So this would be then about, and that would be sharing our terminal side. So to find the measurements of angles that are coterminal that would have a negative 100 degrees, we simply can find those by either adding or subtracting 360 degrees. And there are many different possibilities. We will just find one of those. So if we were to take negative 100 degrees and add 360 degrees, we would discover that the angle measurement we could use for one of our angles is a positive 260 degrees. And if we take a look at our diagram, if we were to go a positive 180 and then we continue around, this would be a positive 260 degrees, and that could be the measurement of one of our angles. Now, if we were to go the other way, which is to take our negative 100 degrees, and this time we are going to subtract 360 degrees, we could find the measurement of another angle that would be coterminal, and that would be a negative 460 degrees. Now we could take a look at our diagram and see what that would look like. So if I begin on my x-axis and I am going to go in a negative direction, which is clockwise, and I were to go around once, that would be 360 degrees, and then another 100 degrees, but this is the negative direction, so that would show a negative 460 degrees, and both of these angles together would be coterminal, and they both then have our same terminal side and would have a negative 100 degrees. Let's take a look then at our next example, which is 575 degrees. So again, take a look. And we want these to be coterminal. So the way that we can find those is to take our 575 degrees, and we can either add or subtract 360 or multiples of those, because there are multiples of 360, because there would be many choices for us to find angles that are coterminal. So first, if we subtract 360 degrees from 575 degrees, we would find out that that would be a positive 215 degrees. So let's draw a diagram of a positive 215 degrees. So if I were to draw in the angle of 575 degrees, we would have our angle first. That would be 360 degrees. And then we come around again for another 180. And coming back down to here would be at 575 degrees, approximately. So if I were to find my first angle to do a positive 215 degrees, that could be one of the angles that I use for my 575 degree terminal side. And that's the one that would be 215 degrees. Now, if I were to subtract 360 degrees again from 215 degrees, that would give me an angle measurement of negative 145 degrees. And if I were to draw this one in on my diagram for my negative angle, that would be from here to here, and that would be my negative 145 degrees. These are two possible angles that would be coterminal, having the same terminal side as the 575 degree angle, one being positive, one being negative. Let's talk again about some other vocabulary words. We want to talk about a radian. A radian is another way that we can measure angles. So far, all of the angles that we've worked with have been measured in degrees, but we can also measure in radians. Now, the definition of a radian is we consider a circle that has a radius of r, and that circle has its vertex at the origin. 1 radian is the measure of the angle in standard position whose terminal side intercepts an arc length of r. So because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. So degree measure and radian measure are therefore related by the equation 360 is equal to 2 pi radians, or 180 degrees is equal to pi radians. So we can use the conversion between degrees and radians. We rewrite degree measure in radians by multiplying by pi over 180, and if we would like to rewrite radian measurement in degrees, we can multiply by 180 over pi. So let's take a look at some examples. If we want to convert 320 degrees to radian measurements, all we need to do is to multiply 320 degrees. We're going to multiply that by our conversion, which is pi over 180. So we can simplify, dividing both by 20, and our radians will be 16 pi over 9 radians. If I would like to convert radians back to degrees, I simply use my other conversion. I have negative 5 pi over 12, and I'm going to multiply that by 180 over pi. Again, I can reduce pi, and I can divide both of these by 12. And so when I multiply, I'll have a negative 75 degrees. So, to review, please remember when your angle is in standard position, the initial side is the positive x-axis. We are measuring an angle with positive and negative measurements. The positive is the counterclockwise direction and negative being clockwise. Coterminal angles share the same terminal side, and a radian is a measurement of an angle where we can use either radians or degrees, and if we want to convert from one to the other, we use these conversions. From writing degree measure in radians, we will multiply by pi over 180, and to turn radian measurements back into degrees, we will use the conversion of 180 over pi.